Everybody. Hope you guys are doing well. So, continuing on our journey in OOP, today we will be uh, starting with we will see what overloading is, and then uh, we will continue with the remaining OOP concepts. Uh, just give me a minute. Just let me check if the stream is up and running. Because sometimes Twitch does not work very good. So just let me check the volume controls as well. Okay. This is like the remaining things that we had skipped. Okay. Let's go back. Okay, so now today we would be seeing another paradigm, which is basically overloading. Now sometimes code becomes more readable when two methods have the same name instead of different names. Now this is known as overloading. So yeah. So now we are talking about something called as overloading. Now this is happens when two methods or two functions have the same name. Um, okay. Now overloading allows us to perform similar operations, but with variation based on input parameters. Now even though the function signature is going to be same, so there has to be something that distinguishes, right, so that the compiler can know which function, or the interpreter at runtime can understand which function is getting called, because we are dealing everything with respect to Java, right? So what the difference is, the difference will be in the number of parameters or the parameters passed. Another okay. Now method overloading should only be used if the code is more readable when the different methods share the same name instead of having different names. Now there is no other reason for performing method overloading. Now method overloading is only possible because the parameter list is different, so that the overloaded methods can only differ by their return type. Otherwise, yeah, that, so what is trying to say is, what if we do not distinguish them between the, if the methods are not distinguished, right? Remember, Java is a compiled language, right? So at compile time itself, we will get an error if the parameter. So whenever you write a method, right, there are three possibilities, right? Either you can change the function name, but then in our case, function name, then you have the list of parameters, and then you have the return type, right? So now remember, in our case, this option is already gone, right? We no longer have this option. So the function name criteria is already taken away from us. Now the other two things that we have is parameter list and return type. What if we keep the same parameter list and then we try to distinguish the function based on its return type, right? Now we cannot do this, because if you do this at compile time, So this return type or this function body will be evaluated at runtime, right? This is a runtime feature. So if we have a different runtime, but the parameter list is same, so at compile time we won't be able to distinguish between the functions and we will get an error. Now method overloading is not an OOP concept. This is a functional programming concept or a functional or a procedural paradigm. So this is just because OP concept, but it is a procedural paradigm. Okay, uh, now some languages might support this, some languages might not. So we might get an depending upon what language you're using, you might or we might not get an error. Let's see instance. Now instance is also another method, right? But the difference is that method is basically used to initialize the instance variables, right? What if we have to what if we overload, like what if we have two instance methods, because ultimately it's a method, right? So the distinguishing factor between which instance method to be called is basically the number of parameters being passed. So let's uh, let's write some code now. Okay, let's where are we here? Where is my main class? This is implements. I already done it. Oh, this is what we were seeing, right? Now these are annotations. So this is basically just an annotation. It's does not mean anything here. Okay. Mm, class. Okay. So what we are going to implement now is basically we'll try to have two instance methods and then we'll see which instance method is getting called when. So let's have a class rectangle, and then let's create an instance. So instance method is created by uh, is created when the name of the method and the name of the class has to be the same, right? So we are going to do it's not returning anything. Okay, so let's in do, and remember the instance method has to be public, right? Because if you make it private, then you won't be able to initialize the so before that, let's have instance variables being declared here. So let's say we have two properties or instance variables. So I'm saying public. Let's say this has to be a width, and then these are instance, and then this is again height. So this is I'm just trying to check whether we can. Now what are we going to pass here is so basically going to call when the function is going to invoke, right? Now we need to pass some local parameters here. So I have width, and then I have an height as well. And then now what I'm going to do is now we need to be so let's make this dot. Now we are making sure that we are referring to the instance variable, right? Is equal to, so this is width again, and then this dot height is equal to the height. Okay. So this is our instance being called. Why we are giving here? This is my class. So now in my main, okay, let's get rid of this. Let's get rid of all those. I should have commented it, but that's okay. Now what we need to do is, okay, oh, class is correct, I guess. Oh, this has to be small case. Yeah. So okay, this has to be a. Let's get rid of this. Now, okay, duplicate class, my friend. Let's ignore that. Uh, mm, okay, so now what we are going to do is we are going to create the object, right? This is my public standard one main. Now, so the object creation will be new, and then I'm going to pass in. Let's pass in 00. Let's have a tab. Now we need a reference to this, right? So the type of variable is going to be rectangle, and then variable name, right? So this is variable. Okay, now let's see what's happening. Now let's go to terminal. Let's say clear all and say, and let's run it. Now we won't be able to get anything here because these are instance, right? What if I add a breakpoint here? Now when I run it, it's still working. I have to do it this way. Then let's close this. Okay, so yeah, getter and setter is okay. Let's have another method which is returning this getter. And then this is taking that instance variable, right? So I have this. Okay, and I'm passing in. Remember, since it's a public method, this can access the instance, right? So I'm going to return this dot wait, whatever it is. So let's we'll be returning something, right? Let's have a return type being mentioned here. This is a return type, and then now let's do this out, and then let's print in we are returning height, right? uh, so now let's come here. Okay, let's go to our terminal. Let's do a clear all and then compile it and then try to run it. Okay, so why uh oh yeah, I missed. Okay, just this is variable or getter, right? There is no method such as height, so let's call it as, yeah. Now it's correct, I guess. Oh yeah, two parentheses. This is perfect, right? Yeah. So let's do clear all. Let's compile. Uh, Hello, just give me 1 minute. Hello. Yeah. So basically, you were trying to understand, right? I mean, uh, uh yeah. So, why did I make this import? Oh, not like this anymore. Yeah. So we had okay. We are returning width, right? And then this is out has to, and then I'm calling this getter. Why is not? Why is this not returning? So return. So I'm having the getter and I'm returning this. What's the okay? Let's system dot on. Okay, high is getting printed. Where is high? I guess let's compile it again so that uh so this is my main class, but there is no high here. Uh, hmm. So I'm doing a return. Where is my yeah? This is my. There's no effect. So let's. I mean, then he's saying, oh, then there's some. Oh, let's get rid of this thing. I guess that is what was causing the issue. Maybe. Mm, yeah. Let's now see. This is clear all. Compile it. Run it. Okay. Yeah. What we can do here is let's have a variable been assigned so that. So let's say double. Uh, and then let's assign it as dot. This is my getter, right? Let's see what sys out of not error and use sys out. So let's write sys out here, and then let's print in. Now if we oh no, we compiled it, right? Uh, okay, what if no? There's something which is not working as it has to be. Set 10 and then pass on 10. First, let's try to compile it. Hmm. Uh, I don't think so. There is any error, but yeah, that's okay. Yeah, this has to be. I guess it's no. Yeah, so I'm returning this dot with right. Another one. I don't think so. There is any error over here. Hmm. Again, the sysout is not working. I don't know. Let's try to. Okay, let's open it again and let's see. Kind of looks like a. Uh, let's search. Do I have a funny folder like that? There should be one. Is this? I don't know. No, this is not what I wanted to open. Let's go to open and then I forgot the. Yeah, this one. Open. So now let's come to which is not printing that uh, uh, high as well. See, the high is not coming. What if we try an online compiler? Let's see. Mm, This is the main, right? It has to be main. Okay. I haven't made this. Oh, let's get rid of this. Let's and then Okay. Instead of having this, let's make this main. And then, yeah, so I don't know why it's an issue, but when I compile it here, I'm getting perfectly the same time. Now, like, what if I have another instance now? So you have another instance. Now, remember, instance is another method, right? So then now what I do is I assign to my width, and now let's start running. Custom width. So based on how I'm going to pass, cannot find symbol. Oh, it has to be capital. So now, even though now I'm passing 2, right? So let's change this and let's have only 10 being passed. See them? Okay, let's make it like 11. No, let's make it 1011. So now 1011, that means this constructor is getting called. And what? Yeah, here let this be width into height, something like that. Now it's not doing any multiplication, right? Uh, so remember here I'm getting 1011. Now what if I do like 10 only? And then I pass out 10. So this should call the one whose parameter list is matching. Yeah, it's giving me 100, right? So this one is getting called. Okay. Yeah, I did constructor overloading as well, right? We did object composition. Now is something now let's see about type conversions, right? Now type conversions can be performed implicit. Okay, now let's get back to our drawing board. Okay, let's write in type conversion. So now there are two types of type conversion one can do. One is implicit and one is explicit, right? You can have both of them. Okay, type conversions can be performed explicitly or implicitly, right? So you have explicit conversions and then you have implicit conversions. Now, now you can also do it using user defined methods or with the help of conversion methods in helper class. Now, once a variable is declared is a specific. Now, this is what happens in a type. What do you say? A type fixed language, right? Once the type is declared, then you cannot change the type. Yeah, if we try to change it, then we might land up in an error. Okay, so now, so what sometimes what the compiler will do is it will promote the type. So the advantage of using or doing that is we are not getting into errors because of type, right? It kind of implicitly promotes it. The first type of conversion that we're going to say is implicit, right? Now, implicit does not require any special syntax. Now, these are basically to prevent any. When we do implicit conversions, there won't be any data loss, right? So it will be always a lower type getting converted into an higher type. Okay, let's see some implicit conversion. So let's see. Uh, okay, so now this is how implicit type conversion will work, right? For example, now this is the root of everything. That means you started from here, right? So character can be promoted to int will be promoted to float can be promoted to boolean, byte can be to short can be to int. Now, this is an remember, whenever we are doing type conversion, we are always going to a higher type, right? So, for example, number, if you see, uh, so this is the least possible memory space, right? A byte, right? Then you have short, then you have int, then you have long. The number or the range of the numbers that this can hold is very less, and it will follow this pattern. This is basically from short to higher, right? So this won't lead to any sort of data loss that is happening. Now this is again one more conversion thing, right? You can do character to int into float, float to boolean. Now the major advantage of implicit type conversion is there is no data loss here. Uh, yeah, there will be no data loss here. But however, explicit when we type convert to try to do, there would be a data loss. And then so implicit is converting a smaller type to a higher type, I feel. Yeah, implicit is so this is converting smaller to higher, right? Not the vice versa. Now let's go to explicit, right? So in explicit type conversions, what we are going to do is we are going to do higher to lower conversion. So it will be a higher type. We want to prefer this because this might need to data loss, right? So basically, converting from a larger superset to a smaller type can lead to data loss. In most languages, we must explicitly tell the compiler that we are aware of this fact and still want to go ahead with the type conversion. Explicit type conversion, while useful, can lead to runtime if the actual data cannot be. Yeah, what happens if it's in the lower type, we cannot accommodate it, then it will result in giving us an error or an exception. For example, string representing non-numeric. Oh yeah. So there is one important caveat, right? What if we try to convert a type? For example, we try to convert. If I say converting string to int, right? Now, where my string contains non-numeric data. In some languages, you get the ASCII code, but this might lead to an exception, right? Because uh, that is how the type is going to give that error, right? Because these are not compatible. These are two different incompatible types, right? So that is why we are getting this error. The explicit type conversion can be done in two ways using traditional explicit conversions. So explicit conversions can be done. There are two ways of doing this explicit. So either is what you do is you mention the type in front of what you are trying to convert. For example, you say int and then put that in parentheses, and then here you have the variable name being written, or whatever type, the other type, right, the smaller one. And then the other way around is basically using x. So this is x as x some type, right? So this is like basically trying to create an alias or something like that, right? As is depending upon your language, either it might support this or that. Now, uh, the difference is both of them performs type conversion. Uh, Here you will get an exception, and here you won't. It won't raise any. This will lead an exception, and this will not lead to any exception. The casting. If cast is not possible, again, if suppose if there is an issue when we try to cast, then we would get an error. Now, upcasting is implicitly by the convert. Yeah, so down converting must be done explicitly, right? We need to mention because type error, and it will not be a safe. It will not be safe. The reason is because it kind of leads to data loss, right? We don't know how much data will be truncated or what will be truncated, so it's better to avoid typecasting. Mm. Okay, so we saw about generics, right? Uh, Now let's see something about interfaces, right? Okay, we didn't see this part, I guess. Uh, Now, in some languages, there is something called as an extend, right? Just like okay. Some languages have this important feature called as extend. Now let's see what does it do. So like we talked something about inheritance, right, previously. Okay, so now let's see the extends in OP, right? Like what does it do? Now we have already seen how inheritance work, right? Inheritance works. So you have a parent class. So this is now where we are talking about uh, inheritance. So let's see inheritance. So this is my parent class, right? And then this is my child. The child will inherit from the parent, right? So So child is going to inherit from the parent. So let's go and then let's see, this is uh, parent, and then uh, this is child, right? So the child class is going to inherit everything from the parent. Now a subclass can inherit variables and methods from the superclass, allowing the subclass. So whatever methods are going to be present here, since we are doing inheritance, those will directly come in the child class. Now so this is okay. This is how you create inheritance, right? You have the extend keywords that is responsible for performing inheritance. But there is one more. There's one more thing in prototype based language. You have something called as extension, right? Uh, Now this is how we do using the extend keyword, right? So this is you achieve inheritance using the extends keyword. Now there is one so this there is something called as extension as well, right? Uh the thing is, now remember, this is, now we are talking about prototype based languages, right? So remember, the whole idea of prototypical based inheritance or prototype based languages, we do not create the actual object, like there is no like class object relationship, right? Those are all value types, right? And they do not have mm, those are like I mean, there is no what do you say, like uh, if you see a class inheriting, right? I mean, the thing is um so this is very famous in a prototype based language, where you have structured and value types, right? You do not want to use so inheritance is basically for class based OOP, right? When you have objects and no, when you have class based OOP. However, when you go to other languages that support prototypic based OOP or prototypes based OOP, you have something called as an those are different, right? For example, in Swift, right, you do not create any class, right? Everything is it's like it's a value type based OOP. Now the advantages is, the what do you say, uh, at time of like memory wastage is less, right? And function reuses more. um, so and these structures are lightweight, right? For example, if you're building any iOS or something, these are all said to be lightweight in nature, right? So now let's see what is the job of this extension, and what is the difference between extensions and in inheritance. So we said extensions will allow to add new properties, right? So you can add new properties, but here what is going to happen is you can add more to the child here, but this is a very traditional thing, right? The methods of the parent will also be present in the child. So here you will have a concept called as overriding. You will override, you will do overriding here. However, in extensions, the only thing that you're going to do is you're going to add a new functionality, but we are not modifying any inheritance structure, right? It remains as it is. So here there is no room for. So the other drawback is we cannot perform overriding. So we cannot do overriding. Okay. Uh, and this is used when I mean, it's more famous when you are in a prototype based language, when you just need to add uh, yeah. So for what, and now in traditional inheritance, when you have a parent or a child relationship, so what you can do is so when you have this parent child or traditional OOP, now this traditional OOP will enable you to do so this is a traditional OOP, right? So this is my uh, parent, and then this is my child, right? So now what, so the methods of the parent will be present in the child, right? So basically here we can do something called as so what if we want to modify the parent behavior, we can override that method in the child. Here overriding can be done, but then when you have extensions or when we use extensions, we cannot do overriding. So that is only the difference between the two. I mean, that is only the major difference between extensions and inheritance, right? So in inheritance, most more first thing is this is a class based thing. This is going to be class based, right? And then the second thing that we are going to do is in inheritance we have something called as overriding, which is possible. You can change the behavior of that class in the child. Now in extensions we cannot do overriding because there is no parent class relationship, but we can add new additional properties or methods to the existing class. So that is the major difference. uh, Now, we now there is some, we also studied something about static, right? Like there is no need to create the class, right? You can do directly. But then there is what do you say, there is a disadvantages as well, right? Now static keyword runs counter to the core ideas in an object, like subtype polymorphism, and can make your code less flexible and difficult to test. Although static seems to be convenient, we should be very we should try to create a normal class, or try to avoid as much as we can try using static, because remember there is it is the main two things that we need to avoid is basically when you uh, what is basically when we are trying to uh, we are trying to test out its functionality, right? So when we do unit testing, it kind of becomes easier when you don't have static classes being mentioned there. uh, yeah, overloading is done. So overloading, okay, so now like what have we covered? Like let's see. So first we saw about classes and objects, right? And okay, we saw this. thing. Uh, then we saw UML diagrams. Then we saw inheritance. This is the first pillar of OOP, right? And then here we also saw the use of super keyword, right? Next thing that we saw was um, generics. So we skipped and we went to generics. Then we defined why do we need, what's the advantage. And then we also mentioned the use of where, right? Basically to add constraints or to our generic types. Then we saw what was object composition, right? And we saw two things here: dependency injection and dependency instantiation. So you have dependency instantiation and then dependency uh, injection. And then we saw private, right? We saw access modifiers, and then now here we specifically saw private, right? And then we saw getters and setters. And remember, Java does not have like a get and set. However, in other there are methods or syntactic words like getter and setter, indicating that a setter has been used or a getter has been used. We also saw um computed properties. Then we saw about properties, right? These are basically uh, variables, instance variables or properties. Then we saw computed property. Now this basically you will have a computation being performed, right? Instead of directly setting or getting it, whenever you're trying to set it, some mathematical computation will be there. Uh, like when we try to set or when we try to get, we'll do some mathematical operation or mathematical computation when we do get and set. The next thing that we saw was so we and then we in here we also saw the base class problem, right? Why inheritance is not the solution everywhere. Then we saw something called as static. Like what is the need to have static and why do we need it? Then we saw encapsulation, one more pillar here. Then we saw overloading. Overloading is when your parameter list is different. But this is actually procedural paradigm. So, but we still cover it here. Then we saw overriding, and in Java you need to use the @override annotation, right? This is basically when we try to change the uh, behavior. Okay. We also saw that static classes are not preferred. Static class are not preferred. However, you can use them. Nothing like uh, it won't work. It will work. Uh, then what did we see more? Well, then we also saw value types. Like we saw proto prototype uh, based OP versus class based OP. Then we saw value types like uh, struct. This is basically with respect to Swift, right? Um, then we understood what. Okay. Uh, then we also studied upcasting, downcasting, right? Casting is something we studied two main things: implicit and explicit cast, and when to use what. Um, yeah, this is all what we have saw. Uh, what we have seen here. Okay, so yeah. Okay. Yeah, I guess that is all for this lecture. We'll continue with some few more OP related paradigm, and then once those are complete, then we will have covered all the topics that we need in OP. So I guess yeah, that's all for today's lecture. See you guys in the next one. Till that time, take care. Bye bye.